All right, today we're going to take a look at directly how do we tell one mineral from another. Just like we can tell you apart from another person using traits like hair color and eye color and height and those sort of things, we can do the same thing with minerals. But what we need to know is what are the properties of minerals. Real quick, I just want to run through what exactly is a mineral because some people get confused. It must be naturally occurring, so something like plastic is not a mineral. It must be a solid, so that eliminates things like water. It has to be inorganic, which means it was never living. So that eliminates like trees and things like that, or fossils. It has to have a definite crystal structure, a specific shape to it, and it needs to be made of one element by itself or a compound of elements. You're going to be taking notes now on this mineral properties note sheet. I'm going to give you this first part right here pretty quick, and then we're going to run through the mineral properties and look at some examples so that you have some understanding of exactly what the different mineral properties are before you have to start using them in the activities that we do. Okay, so when we talk about minerals, what we're talking about here is the characteristics that allow tests to be formed so that we can identify the different ones, basically how we can tell one mineral apart from the other. Again, if I go too fast, please just pause the video and you can write down the notes as you need them. All right, so our first mineral property we're going to talk about is called luster. And this basically is how the mineral reflects light. There's basically two categories we use for luster. One is metallic and one is non-metallic. So metallic basically means that it has a polished metal color. Basically, it looks like a metal. Okay, so pick metal colors like gold, bronze, brass, silver, gunmetal gray. Those are all metallic lusters. I have a note on here that's extremely important for you so that you do not get metallic luster and cleavage, which is a different mineral property, mixed up. Okay, so we can look at a couple of minerals here, and I can ask you, does this mineral, is it metallic? Or is this mineral metallic? Definitely the first one was not a metallic color. The second one was gold colored, so that makes it metallic. So our other type is a non-metallic, okay? And this one means that it is not a metallic color. So we want to think of non-metallic colors like clear, green, blue, red, yellow, white. Those are non-metallic colors, okay? So again, we can try this. Is this metallic? What color is it? It's green. No. Is this one metallic? What color is it? Yes, it's silver. So that's metallic. Moving on. The next thing that we're going to test here is the mineral's hardness. And this basically is how resistant it is to being scratched. There's a lot of things that we use to test hardness, some of them that you have right on you, such as your fingernail, not the girls with the fancy fingernails, but actual real fingernails. The hardness is 2.5. So what we do is we take a mineral like this and we say, okay, does this mineral scratch a fingernail? And we can run the mineral across the fingernail. And I would tell you, yes, it scratched my fingernail, meaning that the hardness of this is greater than 2.5. We can't know exactly, we just know it's greater than 2.5. So the thing we're going to test the most with is a piece of glass. When you test a piece of glass, make sure you put it flat on the desk and you scratch the mineral on it to see if it scratches. Okay. In this case, this mineral did scratch the piece of glass. Okay. So once again, this mineral's hardness is now greater than 5.5. We can't know any more specific than that. There are two other things that we can use. We can use steel to test that. In this case, we use a steel nail to scratch the mineral. We find out that the steel nail does not scratch the mineral, making this mineral, once again, greater than 6.5. We can also use a streak plate, which is basically a piece of porcelain, and we can see if it scratches that. And we can find out that a mineral does indeed scratch this streak plate. So once again, we know the hardness of this mineral is greater than 7.0 now. We can't be any more specific than that. If you do something when you're writing hardness other than greater than or less than, you're just telling me that you don't know how to determine the hardness. That's the example on here. If you wrote 4.7, you're just telling me you don't understand hardness. Okay, so please make sure that you use greater than or less than when you're writing hardness, and life will be wonderful. Okay, our next mineral property is streak. And what that is basically when you take a mineral and you rub it on a streak plate like this, the streak plates have a pretty high hardness, and a lot of minerals will just crumble and break and leave some behind. So to give you an example here, we look at this mineral and it definitely looks like gold, right? It's a gold colored mineral. So if it truly is gold, it will leave a gold colored streak on the streak plate. So we rub it on here and we can see right here that it definitely did not leave a gold colored streak. That is a black colored streak, which means this is what we call fool's gold and not actual gold. Okay, that's how you test streak. The next property we can use is breakage pattern. It doesn't mean I want you to break mineral samples. It means that they broke to be in the size that they're at, and they break along crystal faces, and that produces the specific shapes that we see. So there are two ways that we can do this. If you think of a horror movie or the old cartoons with the butcher running around with that rectangular knife, it was called a cleaver, right? And it would cleave things and make a nice flat cut. And so that's where this first property comes from. It's called cleavage, okay? And that's basically meaning that it's going to break. It's going to have a flat side at least, and it's definitely going to shine when you tilt it. So if we take a mineral like this one and we tilt it, you can see how the light is shining off it. That tells us that this mineral has cleavage. Remember, I mentioned earlier that doesn't mean it's metallic, because this is definitely not a metallic color. Shiny means it has cleavage and not that it's metallic. Okay? We can take this one here, we can tilt it here. Doesn't really have a flat side, doesn't really shine. So it is not, does not have cleavage. This one definitely shines, definitely has flat sides. That one has cleavage as well. Okay, so what's our other example here? Is fracture. Fracture is when it doesn't break along the crystal face. It doesn't shine when tilted. So it's got uneven features to it, like this guy right here. And so that is fracture. All right, moving along. Our next set of mineral properties are the crystal structure. So on the atomic level, the atoms inside the mineral will align themselves and create specific shapes in a lot of minerals. Now, I need to tell you something. In some minerals, it is very, very obvious. It happens on a large scale and we can see it very easily. And so we can use that as an identifying characteristic. In some minerals, it happens on a small scale where you would need to use magnification to be able to see the crystal structure. And so we can't really use it to identify. You just have to use the ones that are obvious. So if we take a mineral like this, we can see it definitely has a crystal structure. It definitely has 6 sides here. So this is an example of a hexagonal mineral, okay? And a mineral that breaks and looks like this, where it's kind of flat like that, that would be what we call monoclinic. Now that was a piece of glass, but not a mineral, but same idea, okay? All right, some minerals have special properties, and these are called special because not every mineral has them, and they are fairly unique, okay? One mineral trait that a lot of students like to use to identify minerals is color, and it's very unreliable because a mineral like fluorite can be colorless, purple, green, yellow, and a variety of colors. So you can't just look at a mineral sometimes and say color is the identification. We can use it in some cases because, for example, a mineral like olivine is olive green. That one we can use. A mineral like sulfur is yellow. That one's pretty easy to use it for. Some minerals turn out to be magnetic. So like you can take a mineral like this, you can take a magnet like this, and you can put it on the mineral and it stays, okay? So that is a magnetic special property. Some of them, it has to do with how they feel. Some of it has to do with how light passes through them. And you can even put a drop of acid on some of them. Hydrochloric acid, it will fizz like soda. Some of them, if you put them under UV light, they fluoresce. That's the blue mineral you can see in this picture. So these are some special properties that a few minerals have, but not very many. All of these things can be used to identify minerals. So you should have this sheet completely filled out now, top to bottom. And this is important because the assignment you're about to do, you're going to use these notes to do the assignment. So if you don't have the notes, you can't do the assignment. Good luck.